So the next topic we're going to cover is how to group the different methods in the Completable Future API up into categories. And you'll see in a second why this is so useful to do. And the reason, of course, for this is there are lots and lots and lots of methods that are part of the Completable Future API. There's actually over 60 methods now in the latest versions of Completable Futures, and they all reside in one class. So essentially, the Completable Future class is a facade for a much more complicated set of mechanisms under the hood that perform all these asynchronous computations. And a facade is just a gang of four pattern called the facade pattern, and it basically provides a simpler interface for what under the hood is a very complex set of capabilities. In fact, there's also probably another 24 nested classes inside of the Completable Future class. So it really is a framework behind a facade API. And these methods can be broken down into categories, which I show here. And we're going to talk about these. We'll talk about basic methods, factory methods, completion stage methods, exception methods, and arbitrary-arity methods. So it really helps to kind of have a bird's eye view of what's happening rather than just getting lost in the details of dozens and dozens of methods, which gets, quite frankly, a little intimidating at first. I know when I first was exposed to Completable Futures years ago, I was like, what the heck is going on here? It's way more complicated than I could ever imagine. So we'll talk about all those different issues. Some of the methods that are in Completable Future come straight out of Future. So these are the so-called basic methods, not that they're written in the basic programming language, but they're just very simple. They do very little beyond what you get out of the box with just a regular old Java Future. And that should be no surprise because Completable Future implements the Future interface. So it will have some of those core methods. Then, as you can see here, there's a few more methods in Completable Future than there are in the basic part of Java Future. There's a few other methods that are kind of the basic part of Completable Future, but it looks very much like what you get out of the box with Future. Then the bulk of the methods, and certainly the ones we're going to focus on, are the ones that are the more advanced capabilities. And these include the factory methods, completion stage methods, exception methods, and arbitrary-arity methods. And I think you'll be really interested in these styles of methods because they do some very, very powerful things. So let's start with a quick overview of factory methods. Again, I'm just kind of giving you the bird's eye view right now. We will clearly go into this stuff in much more detail in the not too distant future. So what is a factory method? Well, of course, you hopefully remember factory method pattern from Gang of Four book and other patterns-oriented literature you may have read or been exposed to in other classes or through your own self-study. And a factory method is basically something that creates a result. And in this case, there's 4 factory methods that are defined in the Completable Future API. And they're 2 pairs. The first pair will initiate asynchronous two-way communication. And these are the supply async methods. And the second one is, the second pair is called run async, and that initiates one-way computations. And what's cool about these methods, in addition to the fact that they integrate with everything else in the Completable Futures framework, is they all work without having to spawn threads explicitly. So when you use these mechanisms, these methods that are the factory methods, they will use some kind of thread pool, either the common fork join pool, which is what they do by default, or you can actually give them your own pool. And why this is useful is because it helps to make programs more elastic, thinking back to those principles of reactive programming, by leveraging a pool of worker threads. So you don't have to do this stuff. You can just start something up asynchronously, and then under the hood, it's managed elastically by the underlying thread pool that you chose. And again, there are 4 out of 60 methods or 60 plus methods are factory methods. The vast majority of the methods that are defined in the Completable Future API are the so-called completion stage methods. And I'd say there are probably like 40 of them. So it's a big number. These are used to chain together actions that will perform processing on the results of asynchronous computations when they complete. So these are what are often called dependent actions. So you initiate something with a factory method like supply async, And then you can typically have a chain or a fluent chain of completion stage methods, and they'll get called one after another as the previous stage completes. So that's the main purpose of completion stage methods. There's also the concept of composition, and we'll talk about that shortly. A good place to learn about the completion stage methods is by reading the completion stage interface documentation. I strongly encourage you to do that. That's at the link at the bottom of the page. They do a really nice job in that document of explaining what each of the completion stages do. So it should come as no surprise that the Completable Future class implements the completion stage interface just like it also implements the future interface. So a completable future is essentially a future plus completion stage methods. And we'll talk a lot more about those as well. The completion stage methods help to make programs more responsive by not blocking the caller code. And we'll see there's a whole bunch of different ways that that takes place with completion stage methods. So as a result, going back to this concept of synchrony versus asynchrony, with asynchrony, the caller thread doesn't block, and the callee goes off and runs in some worker thread in a common fork join pool or some other thread pool that you may provide. So we're not blocking the caller code, so that allows that thread to go back and wait for input from the users in a more responsive way. Yet another category of methods are called arbitrary-arity methods. It's kind of a funny word. Arity is just the number of parameters that are passed to a method. So we have binary, which is 2, and unary, that is 1, and ternary, that's 3, and quaternary, that's 4, and so on. So it stands to reason that arbitrary-arity means you can pass an arbitrary number of parameters. This is implemented in Java, of course, with var_args types. And there are two arbitrary-arity methods, one of which is called all of, and the other which is called any of. And you can see they both take essentially a var_args list or an array, an arbitrary sized array worth of parameters. And in this particular case, all of, as the name implies, will return a completable future. Will return one completable future, and that completable future triggers when all of the parameters are going to be finished and they all complete. Then that one returned completable future itself will complete. So it depends on all the other ones finishing. That's why it's all of. And the other one is any of, which says when the first of all the parameters passed in completes, then the completable future completes. So you can wait for all of things or just the first one. And again, much like the completion stage methods, the arbitrary-arity methods help to make programs more responsive by not blocking the caller code. And they're actually really powerful. Now, you're going to end up using the arbitrary-arity method all of in your programming assignment that you're working on now, except that it's going to be wrapped up in this really cool thing called the future stream collector. And we'll talk more about that later when we talk about arbitrary-arity methods in more detail. Yet another type of advanced completable future API category are the exception methods. And what they do, as the name implies, is they help to handle exceptional conditions that occur at runtime. And an exceptional condition is something that throws an exception. And we'll see there's about 3 or so different ways of handling exceptions, and they come with different pros and cons and different capabilities. So we'll go through all of those later. The main capability that's provided by exception methods is to help make your programs more resilient by allowing things to continue executing even if an error occurs. So if something goes wrong, you can catch that exception and you can handle it, or you can propagate it in such a way where that particular computation shuts down cleanly, but you don't take the whole program down with you, which is really the goal of doing these kinds of things. You want to make sure that your system will be resilient to partial failure, and the exception methods help to ensure that. All the methods that I just outlined, the different categories, the factory methods and completion stage methods and arbitrary-arity methods and exception methods, and for that matter, even the basic methods, they're all implemented internally using message passing that's ultimately connected with different types of Java-based thread pools. So once again, kind of going back to the principles that we've talked about earlier for reactive programming, the mechanism here is message driven, even though we have a nice method-oriented facade exposed by the Completable Futures class API itself. Internally, there's this message passing framework that enables loose coupling, isolation, and location transparency, using the word location transparency somewhat loosely here. Really, core thread transparency is a better way to put it. It's actually always going to be running in the same address space in a process, but we don't care what core a given operation is running on asynchronously. So that's the end of the overview of the groupings of the methods in the Completable Futures API. Obviously, you still probably don't know enough to start cranking out the next assignment, but as we go a little deeper in each of these topics, you will get to see many examples to illustrate this in more detail.